Okay, let's do a second example of partial fraction decomposition. Like I said, I think it takes a couple examples to really get what's going on and become comfortable with the methods. So give yourself a chance, write these down as I'm writing them down, and then, grab some problems from the text or from your homework to do some extra practice on them. And then I think you'll get them. So the second example of case 1 is 4 over x times x minus 1. If you can remember what case 1 meant, it was that the denominator was made up of non-repeating linear factors. So they're not repeating because one is x and the other is x minus 1, and they're linear because it's a single x, right? Okay, so what we want to do, our goal is to break this fraction up into two parts. The denominators will be x and x minus 1, okay? But we don't know what this numerator is. It's not just 4. That wouldn't make sense. So it's going to be a and b again, okay? Now, remember what we did to start the problem, and that was clear the fractions, right? We clear the fractions by multiplying by all the denominators, right? So the x times x minus 1, the least common multiple. And it's always going to be this denominator, actually, that you have to multiply by, okay? Because that'll be all the denominators, and this is the parts of the denominator over here on the right. Okay, when we do that, we multiply x times x minus 1. Over on the left side of the equation, all the denominators divide out, and we only are left with the 4. Over here, the x over x divides out, so we're left with a times x minus 1. Finally, the x minus 1s will cancel out here, so we're left with bx. Okay, so now we're going to simplify this and kind of collect those x terms together and see what happens with our system of equations. All right, so we have 4 equals ax minus a plus bx. So I want to collect the x terms together. So that would be equal to ax plus bx, and then still minus a. That's still 4. And then I did do that extra step this time. This is the GCF, x times a plus b minus a. Okay, so to set up our two equations, we need to think about how the left side of the equation equals the right side of the equation. Okay, so this time, notice there's just a 4 over here, no x. So in other words, this is 0x plus 4. Okay, so the x term is right here on the right, changing it to orange. Okay, I'll leave the other one blue. So this is the 4, the constant term. Over here, the constant term is minus a. Okay, so we have two equations again, one in orange and one in blue. The orange one over here is 0 equals a plus b, or a plus b equals 0. The blue equation, and that's from the x terms, okay, that's the coefficients of x. The blue equation is 4 equals negative a, and that is the constant terms put together. Okay, so with these two equations, actually, this is going to be a really simple system to solve, right? I told you the systems would be easy. We have a is negative 4, right, just from the second equation. So then in the first equation, if we plug in 0 equals negative 4 plus b, we get b is equal to 4. So we've already found our answer. So exciting. This is equal to negative 4 over x plus 4 over x minus 1. Okay, so this is the same. So we actually have a negative 4 and a positive 4 there. We need to work those out every time. They don't really follow a good pattern.